All right, hi everyone. We'll get started. Thanks for being flexible today. And as a fair warning, my Airbnb is getting checked at right now, so if you see people walking in the background, just ignore them. Okay. What do I have to say? So you have a quiz on Monday, and then an exam on Friday. So just be prepared for that. If you have any questions in the meantime, just let me know, let Dr. Altomos know. He'll be happy to get that for you. I'll put together last week's practice problems and this week's practice problems and get those out to you by this weekend so that you have that to practice for the quiz on Tuesday. All right. Any questions for me on what you would like to see today, or just general course questions in general? You can use the chat. Yeah. Yep. Okay. Let me pull up the slides from today. All right. So when we talked about today, or I guess what y'all talked about today, because I obviously wasn't there, is the ability for a solution to be acidic or basic, depending on what the salt and compound is, right? So when we talk about sodium HCO3, right, what we want to look at is where do these components come from, okay? So if we look at something like the compound here, we want to break it up into the cation and the anion. So where are we going to break that apart in terms of a cation and an anion in our compound?
Na and HCO3.
Perfect, right? So Na becomes Na what? Plus or minus.
Plus, I could be wrong.
Yep. Right. Sodium is a metal that's in our group 1, so that's going to be sodium plus. And then this must mean, right, we have a neutral compound, so this must mean that HCO3 minus is our anion component of this. So once you break those apart into your cation and anion, you want to say, what does this come from? Okay. So what is the, right, if we have a plus, that means if we look at, right, if we compare conjugate acid to conjugate base and stuff like that, if we have an acid, right, our conjugate base is the minus sign. And then if we have a base, I guess if we have a base, then H plus, HB plus is our conjugate acid, okay? So for the plus, that's like technically our conjugate acid. So we want to ask, what base did this come from? What base does Na plus come from? It's kind of a trick question. See if you all get it.
Sorry, I don't know.
Yeah. So if we have, does anyone know our 6 strong bases?
I think it's HCO, H NO3? No. And then HClO2?
Yep. Then we have HBr, HI, and HNO3, right? So these are our strong acids. Our strong bases are lithium hydroxide, sodium hydroxide, calcium or potassium hydroxide, and then calcium hydroxide, barium hydroxide, and strontium hydroxide. Okay, so what's important to know about these is that if you see a cation from any of these bases, right, then you know that your conjugate base, or that the base that it came from, is one of these strong bases. So does sodium come from one of our 6 strong bases?
Sodium, no. Oh, sorry, yeah. There's NOAOH, but that doesn't count though.
Say it again.
There's NaOH, but it doesn't count though, right? Because
Yep,
it is.
that counts. Yep, that counts.
Oh, okay.
Right? Because if we were to break apart sodium hydroxide, it's going to break apart into sodium plus and OH minus. So that sodium plus here matches the sodium plus here. Okay, so it came from this sodium hydroxide base. Right? That's where that Na plus ion came from. Does that make sense?
Yeah, yeah, it makes sense.
Okay. So, right, we have the NaOH, right? If we had Cl minus, then that would have come from HCl in terms of an acid, okay? When we look at our HCO3 minus now, is that one of the ions that we see in our strong acids, right? If we split this apart, this is H plus and Cl minus. This is H plus and NO3 minus. Do we see HCO3 minus in any of our 6 strong acids?
No, wait, is HNO3 repeated?
Oops, it is.
What was it? Oh, H2SO4.
Yep, H2SO4, sorry. Yep, so still, do we see HCO3 minus in any of our strong acids?
No.
No, we do not. So then we have to look back at our rules up here in terms of where did this come from? So, right, if this is a minus and we're looking for the acid it came from, are we going to add a base or add a proton or subtract a proton, right? Do we need another H or do we need to get rid of an H to say, where did this come from?
Add a proton, so add an acid?
Yep, so it becomes an acid, so it's going to be H2CO3 as our original acid that it came from, right? So this is our acid. Okay. Now we have to compare the base that it came from and the acid that it came from. Is our base strong or weak?
Our base is weak.
What is NaOH? Is that in our category down here?
Oh, sorry, I read the acid, sorry.
Yep.
So then NaOH, yeah.
Yep, so NaOH is strong. And what about our acid? Is our acid strong or weak?
Weak.
This is weak, right? So if we have a strong base and a weak acid, right, which one's going to win the arm wrestle? The strong base or the weak acid?
Strong base.
Strong base is going to win, which means that our salt is going to be basic. Right, that basic component is stronger than the acidic component, therefore making it a basic salt.
Okay.
Okay, do we see where that came from?
Mhm.
Okay,
So in every type of problem, is water always gonna be a part? Like I'm just saying, like for the NaOH, and
yes.
you
Yep,
just got okay.
yep, because, right, what we're pretty much doing is saying that, okay, we're forming aqueous, right? And we have H2CO3 aqueous, and we are switching our partners, right? So we get NaHCO3 and H2O. Right? We're essentially just writing the chemical equation. We're just kind of going backwards in this case.
Okay.
Okay. But they're always going to be aqueous, so they'll always be a part of this. The water will always be a part of a solution.
Okay, so it's aqueous means that there's always water.
Yes, yep, because your aqueous means that you're dissolving that thing in water. So water's always around for you to interact with.
Okay, thank you.
And then someone in the chat asked if they are strong, both a strong base and a strong acid will be neutral, and that is correct, right? So if we had something where it was like, oops, right? If we had something where it was sodium hydroxide, actually, yeah, let's do this. If we had NaCl as our salt, where does our sodium come from, right? That becomes Na plus, and this becomes Cl minus. So what does sodium come from? What base does sodium come from?
Oh, NaOH.
Yep, perfect, comes from NaOH. What acid does fluoride come from?
HCl.
Perfect.
Or it could be HCl. No, it does have O4.
Yep, it's HCl. Yep. So if we have NaOH and HCl, what do we categorize this as? What is sodium hydroxide as a base? Strong or weak?
Strong.
Strong. And what about HCl? Is that strong or weak?
Strong.
This is strong. So if you have two strongs, right, that's like a tug of war where they're not going to move anything. So that's going to be neutral. Or that's an arm wrestle where they're not going to have favoring to one side. So that'll be neutral. So NaCl is a neutral salt.
And would the same be with weak acid, weak base?
No. So weak acid, weak base, you have to do a little bit more stuff. So more often than not, we'll either ask you for that something that comes from a strong acid, strong base, or a strong acid, weak base, or a strong base, weak acid. If you are looking at a weak acid and a weak base, then you have to compare either both of their pKa's or both of their pKb's to see which one is the stronger acid or which one is the stronger base that way. It gets a little bit more complicated. I think you will talk about that a little bit, but I don't think that's a question that you'll be asked about.
Okay.
Yep. If you are asked about that for your homework, right, if you have a weak acid and you have a weak base, then you need to say that the larger, right, we know that the larger Ka is the stronger acid.
Okay.
Okay, so you have to compare those together. So if the weak acid has a stronger acid, is the larger Ka, then that would be an acidic salt. But I wouldn't worry too much about that one.
Wonderful. Okay.
Okay, now let's do the other, or let's look at another example. Okay, so you might have done this one in class today, but we'll go over it and work through it together, right? So this is, what is the pH of a 0.25 molar ammonium chloride. Solution at 25 degrees Celsius. And we know that ammonia, NH3, has a KB of 1.8 times. Oops. Right. Okay, so let's think about this first, right? What is it asking and all that, right? We need to say, we're asked for what is the pH of a 0.25 molar ammonium chloride solution at 25 degrees Celsius, okay? So let's first classify NH4Cl as acidic or basic. Okay,
I know HCl would be a strong, or are we saying for this, or are we separating into the strong acid and base?
perfect. Yep. So where do these come from, right?
HCl and HNO3? Oh, no. Yeah. No? No, there's no oxygen.
Close.
I'm tripping.
Very close. So we have, right, let's break it apart into its ions. We have NH4 plus and Cl minus, right? We know Cl is just a minus, so that means NH4 plus is here. We said that Cl minus comes from HCl.
Mhm.
But what does NH4 plus come from?
NH3, but
NH3, yes. Right,
oh,
we have the plus, which means we have to go back to our, right, base and acids up here. And if we have the HB plus, that means that we have the base is now protonated. So we need the base that it comes from, which is going to be minus one base. That's going to be ammonia. Okay, so what is ammonia? Is that a strong acid or a strong base or strong acid? Wow, is that a strong base or a weak base?
weak base.
This is a weak base. And what about HCl? Is that a strong acid or weak acid?
Strong acid.
That's a strong acid. Okay, so is NH4Cl a acidic or basic or neutral salt?
It'd be strongly acidic.
It would be acidic salt, yeah.
Okay.
Perfect, because our acid is more is stronger than our base. Okay. Questions on how we solved that so far? Does that make sense how we tell the difference if it's acidic or basic?
So is it always going to be acidic whenever the stronger acid, or whenever the acid is stronger than the base, and then basic whenever the base is stronger than the acid? Whichever
Correct.
one is.
Yep.
Okay.
Yep. So then, right, when they're both strong, then it doesn't really matter. So that's when it becomes neutral.
Could we have solved it by just using the KB?
You could also have done that. Right, but the question is asking for the pH of a 0.2 molar ammonium chloride solution. And gives you the KB. So it's not right. My question is this an acidic or basic salt to begin with? So it's not the same question technically.
Ah, okay.
Yep. You can look at the KB. You just have to remember like what the KB means and stuff. So if you can break it down into the ions, I think visually it helps it a little bit more as well.
Okay, thank you.
Yep. Alrighty. So what do we do in order to actually solve this question? Right? How do we keep how do we keep going?
Do we write an equation and then make an ice table?
Yes, and what would that look like?
I'm not really sure. I was gonna ask if this is given like as a product or as a reactant.
Yep, so basically what we're saying here is like, so once we have this salt, right? We said NH4Cl is going to break apart into NH4 plus and Cl minus. If something's strong, we don't really care about it anymore, right? We know that water forms at the very end. So, or like water's in our solution. And once we have that, then we can say, okay, Cl minus is not going to do anything with water. If water transfers an ion, then we get HCl, and that's just going to dissociate again into H plus and Cl minus. So it just stays as chloride. We don't care. If H plus, or if NH4 plus gives an ion to water in this case, here, I'll use a different color, right? If this becomes the transfer, and we get NH3 and H3O plus, now we've set up a solution with a weak acid and a weak base. Okay, so we're going to rewrite the equation to say NH4 plus with water now gives NH3 and H3O plus.
So is NH4Cl just not part of the equation at all?
It is a part of the equation, but think of it as like a solid that is being dissolved in solution. And the consequences of it being dissolved in solution are these ions forming. And now what do those ions do as a result of being dissolved?
Okay. And then when they give like NH4Cl, is it given always as a reactant? Like do they always give the reactant first? Or do they sometimes give a product?
Yes.
They
Yes.
always give the reactant? Okay.
Yes. Okay, does that make sense how we like kind of set this up, right? NH4Cl is going to go into solution, forming the ions of NH4 plus and Cl minus. And then we have to ask ourselves, what is that what causes or what happens after that now that those ions are in solution?
And
Chlorine,
why
not
do
gonna
we
do
Oh,
anything.
sorry.
Sorry, go ahead.
Why do we not add water on the reactant side?
You can do it that way as well. I always put it on the product side because then I'm saying, okay, all of these things are now in solution. My ions and my water, what happens when all of these are together? Like that's just a way that I ask myself that to kind of see what's going on. You could write it like this as well. But it's not technically a balanced equation because you don't have another oxygen in there, right? So it's like, it just looks a little funky that way if you write it that way.
Okay.
I don't think you'll ever be asked to actually write this equation. You just have to know what's happening. And if it's easier for you to put water on the left, or it's easier for you to put water on the right, it's just like something that'll be on your scratch paper that neither one of us will ever see.
So are we never using like that single ion if it's like Cl, or we like had a question in class today where it was like the potassium ion? We just like leave that out and then start the new or the second step equation where you did like the ammonium with the water.
Yes. Yep.
Okay.
Right. Usually you'll have an acidic or basic salt in these types of questions. So one of them will be strong and one of them you can just ignore.
Okay.
The
Thank
other
you.
one is what we care about.
Okay.
Right. With like strong stuff, they're just completely dissociating and they're boring. The weak stuff does the chemistry. Okay. Yes. So someone asked a really good question. Someone said, do we know to use H3O in the equation instead of OH since we found the equation has strong acidity? And that's correct, right? We know that at the end of the day, this salt is acidic. Therefore, we should see acid showing up in our overall equation that we're working with because we need to produce those acidic ions that makes the salt acidic. Okay, so that's a really good observation. If we have a basic salt, then that means we're going to be producing OH minus ions. All right, so we can keep going. So we have NH4 plus and H2O. That's going to form NH3 and H3O plus. Okay. We're now going to form our ice table. Do we care about water?
No.
Nope. Okay. What goes into our initial concentration of NH4 plus?
.25?
0.25. Yep. And right, why is that the case? When we break NH4 plus into NH4 plus and Cl minus, or I'm sorry, when we break NH4Cl into NH4 plus and Cl minus, everything is 1 to 1 to 1. So that entire concentration of the 0.25 molar will also be 0.25 molar for your sodium, for your ammonium ion. This is going to be 0.25. And what do we put in for NH3 and H3O minus, or H3O plus?
0 and 0.
Yep. So what does that mean
Quick
for our ice
question.
table? Absolutely, go ahead.
If Cl was included in this, since it's an ion, would we just ignore it in ice tables?
Yes. Yes, because we don't care. It's right. The Ka or the Kb is right. If it's the Ka, it's the conjugate it's the acid and its conjugate base, and then the H3O plus ion. So chlorine in there does not fall into any one of those categories, right? The chlorine is not the acid, it's not the conjugate base, and it's not the hydronium ion. So we don't use it in our ice table because that's not contributing to Ka.
Okay, thank you.
Does that make sense?
Mm-hmm.
Okay.
Because we're only
Alrighty.
focusing on acid
So
and bases and not whatever that is.
Correct. Yep. It's not when you can't categorize that as something that you would put into the Ka. Okay. So then for our change, what is our change here? But we have to form some of our products. So we'll have minus X, plus X, and plus X. And then what do we end up for? Our equilibrium is 0.25 minus X, X, and X. Okay. What are we solving for?
H3O?
We're solving for H3O, right? We're looking for the pH. So what are we using? Are we using Ka or Kb?
KB.
We're using
Did I say it wrong? Ka?
Ka, we're given Kb, right? So that's where you have to think for this problem especially. You're thinking the whole time, but critically think here, right? You have Ka is equal to NH3 times H3O plus over NH4 plus. Okay, that's Ka, the acid and its conjugate base in the hydronium ion. What are we given?
The Kb value earlier.
Yeah, we're given the Kb value of ammonia. How do we get the Ka of ammonia?
Divided by, or no, 10, it's 1 times 10 to the negative 14 divided by the Kb value.
Yep, so how you did that was we said Kw is equal to Ka times Kb. Yep.
I have one more
So-
question.
Yep.
So I thought that the H3O was interchangeable with OH, right?
No, H3O plus is interchangeable with H plus.
Oh, okay. That makes sense.
Yes.
Okay, thank you.
So we have 1.0 times 10 to negative 14 is equal to Ka times 1.8 times 10 to negative 5. So we get Ka is equal to 5.56 times 10 to negative 10. Okay. What can we do to, or any questions on how we got to Ka or why we need to use Ka? Big silence, that's a no. Okay, so then now we have everything to plug into our Ka formula. So we have 5.56 times 10 to the negative 10 is equal to x times x over, are we able to use the approximation here?
Yes.
Yes, yep. 0.25. So we get x squared, I guess, let's do it open. X is equal to 1.18 times 10 to the negative 5 molar. Does that answer our question?
Mm-hmm.
Close.
We need to do the negative log.
Good, right? We need to say pH is equal to the negative log of the hydronium ion. So negative log of 1.18. And we get negative 1.07. What does it mean if it's negative? Oh, I did that backwards. Hold on. Sorry. I got 4.9. That looks better. Is that what we got as well? Okay, so right at the end of a question, you always want to make sure you ask yourself, does this make sense? Right, I did that and I said no. So I knew that I did something wrong and I plugged it into my calculator wrong. But when we're looking at the pH, right, let's check back to what we saw. pH is 4.93. That's in our acidic range on our pH scale. We said at the beginning that NH4Cl is an acidic salt, so we should end up in the acidic range. So the acidic salt matches the acidic pH, everything checks out. We also know that NH4 plus is a weak acid. So it shouldn't be in our very weak side or our very strong side of the pH scale, like in the zeros, ones, twos, or even the negatives, right? It should be closer to that neutral range because it's not as strong as some of our other acids that we work with. So 4.93 is pretty reasonable. So you should say that this all makes sense.
Also, earlier, did you say that we're gonna have to know how to write the equations, or did you say that we're not gonna have to know how to write them?
No, you shouldn't have to. It would just be like something you're writing on your scratch paper.
So if we don't need to know how to write them, then how do we create our ice tables?
So I mean, in terms of like, sorry, you don't need to know how to write like this portion here. Right? You don't need to come up with a proper chemical equation when you're breaking up your salt into its ions and then interacting with water.
Mhm.
But you will need to know, okay, I've now created a salt, right? I now have, or I'll do this one. Right, I now have this salt. It breaks apart into Na plus and HCO3 minus. This comes from NaOH. This comes from H2CO3. This is a strong base. This is a weak acid. I don't care about this. So this in solution is going to be HCO3 minus plus H2O, going to form H2SO. Oh my God, I keep doing that. H2CO3 and OH minus. This,
Oh, so whichever like is the weak one, like whether it's a weak acid or a weak base, that one becomes the reactant, and then you
Correct.
add it to water. Okay.
yep, yes.
Okay.
Right?
Thank you.
Yep, of course. So like that last equation is what you need to know in order to write your ice table. And it should always come out, right? If you're saying, is this an acidic or basic salt? When you say, okay, this is my weak acid or this is my weak base it's coming from, you should see both of those components in your final equation that you write, right? You have your base, you're forming your conjugate acid. And you have your base and you're forming your conjugate acid. Right, so you should see those on both sides of the equation. Does that help there?
Yes, it makes sense. Thank you.
Yep. Right, so you can go and you can like do this question here, and if I said, what's the pH? And I said that the Kb of HCO3 minus is 2.5 times 10 to the negative 5. Right, you could now solve this question as well. Do we want to do this question that I just came up with as practice? Sure, okay. So, right, going back to our salt, what is NaHCO3? Did we say that that was acidic or basic salt?
Is it acidic?
Right, let's
Oh.
look at what it came from. So we had NaOH, and so we had NaOH and H2CO3. What is NaOH? Is that a strong base or a weak base? Good. So this is going to be a strong base, which means that between a strong base and a weak acid, which one is going to win? Or what does that make the salt?
Basic.
Basic, right? So this is going to be a basic salt. We all see where that's coming from? Good. So we don't care about our strong base component. We just care about the weak component. So we're going to take our weak base and we're going to add it to water to form our weak conjugate acid and OH minus ions. We're going to form our ice table. I didn't tell you what the concentration is. So we'll say concentration of Na8CO3 is right, we'll just do one. We'll do 0.25. Okay. So we are going to plug in 0.25 in our initial for HCO3 minus. We'll have 0 and 0. We'll have minus X, and plus X, leaving 0.25 minus X, and X. Can we use KB directly this time?
Yes.
Yes, we can. Yep. So we'll have, right, KB is equal to H2CO3 times OH minus times HCO3 minus. We can plug all of that in. Can we use the approximation here? Yep. So we can have 0.25. So I got X equal to 0.0025. Did anyone get something different? So now that gives us X, what can we do with X? What does that tell us?
We can use negative log.
Yep, so we're going to take the negative log of 0.0025. And we get 2.6 as that answer.
Isn't this supposed to be basic though? So does it have to be past 7?
So what did we solve for when we did the negative log?
Oh, did we solve for POH?
We solve for POH.
Oh, okay.
Right? X here is the concentration of OH minus. So this is the POH equal to 2.6. So how do we get to a pH?
Just subtract it from 14.
Right, we'll have 14 minus 2.6. And we get 11.4. Now, does that make more sense?
Yes.
Yep, perfect. Right, so you did that where you're like, does this make sense? You said no. So we have to go back and check what we actually solve for. We solve for POH, not pH. So we just need to do that last final step to get to 11.4. which is in our basic range, is kind of about the same as like the 4.96 that we just solved. So that's good, right? Our weak acids and weak bases should be somewhere in the middle of our basic and acidic ranges.
I'm a little bit confused about like the beginning part about the equations, like writing them. Whenever we're finding, like, I guess what I'm asking is like, why is OH in our equation rather than the H3O or H plus?
Yep, so that's a great question. So when we're looking at salts, we have to ask ourselves, what is this coming from and what is the weak component of our salt? So let me try and find just a different example so I'm not using the same one the whole time. Okay, so if we have something like KCN, okay, when we break this apart, we need to ask ourselves, what ions does this break apart into? So question one, what do those break apart into?
Potassium and then cyanide.
Perfect. So you have K plus and CN minus. And your plus will always be, right, your conjugate acid, and your CN minus will always be your conjugate base. So you need to ask yourself, what base did this come from and what acid did this come from? So looking at potassium, what base did that come from? What is its original base that produced a calcium plus ion?
I'm not sure. KOH?
Yep, yeah, perfect,
Oh,
right?
okay.
KOH, right? Whenever we see one of those ions that looks like, right, something from our strong bases. So if you see anything that's a lithium, a potassium, a sodium, a calcium, a barium, or a strontium, those will always come from KOH, right? Looking at like the conjugate acid and conjugate base stuff, we know that our plus always has an extra hydroxide ion, right? Our conjugate acid always has a hydroxide. There's no hydroxide for us to take away in this case. So then if there's no hydroxide there, we have to think, oh, this must have come from an OH minus and it produced OH minus ions. So it's probably one of my strong ones. If there's an H plus that you can get rid of, then that's when it's looking more like a weak base situation.
Okay, thank you.
Yep. And then so someone asked, and that's, we can keep going with this one, but someone asked a really good question. They said, so whatever is the weak acid or base in the original equation becomes the reactant, and that's correct. But whatever is the strong acid or base determines if we use OH or H3O plus in the products. That is correct as well. So I'll show that in a second, right? We said that KOH is the base it comes from. And is that a strong base or weak base? KOH was a strong base, right? Now we have to look at cyanide, right? We said that cyanide was the conjugate base, which means it's missing a hydroxide because the acid would give up its hydroxide ion. So what is the acid that CN minus came from?
Is it just HCN?
Yep, so this is just HCN. This is now our acid, and is this a strong acid or a weak acid?
Weak.
It's a weak acid. Perfect. All right, so the original, whatever is the weak acid or base in the original equation becomes the reactant. Yes. So which one becomes our reactant in our next equation? Which one do we care about? We care about the strong base because that's going to tell us to use OH minus ions, but this CN minus is what becomes our reactant. Okay, so as we're writing our equation, we're saying, okay, CN minus plus H2O, right? We'll always have whatever that original ion was in water. Is there an H plus on the CN minus that we can give to H2O? No, right? This is now looking like H is going to be transferred from H2O to HCN to form the HCN that we said it comes from back here, right? This matches. So if we're giving up a H plus ion, that's going to form OH minus. We said that our strong base in our original. So that means that we need to have OH minus in our overall equation when we're writing that new equation with the weak reactant. Does that help a little bit? Or did we make that more confusing? We can practice with one more. Let's do. Let's do. Okay, try this one. Let's say determine okay. All right, so answer those two questions based off of NH4 and L3. Okay, I'll give you a couple minutes, right? And we'll talk about it right before we end the session. Alrighty. Did we determine if NH4NO3 is acidic or basic? Any idea? Yeah. And NO3 minus. We need to our base, which means we need to our conjugate base. We need to have our conjugate means we need to add an H plus. So we're going to have and is a weak HNO3 all is going to win plus in our equation that we're going to write next. Okay, any questions how that analytic salt? All right, so then now we're going to take our thing that is weak, our NH4 plus. And that plus means that we have an extra H plus ion. Going to donate it. Okay, so you can use this in order to write your ice table based off of any of the other information that you're given in that question. Okay, does that help with some of the stuff that we did in class today? Are there any other questions on nonsense? Okay, great, perfect. Well, if there are no further questions, I will let y'all go for today. Thank you again for being flexible, and I will see you in class on Friday if you have additional questions. And if you do have more questions and you just don't want to ask them in front of people, I'll hang on for a couple minutes before I head over to the next one. Thank you. Thanks for coming.